Alright, so let's start today's lecture. So this is just a recording for everybody. So first of all, happy Thanksgiving, and hopefully all of you will have a joyful and graceful Thanksgiving. Today's recording is going to be a little bit shorter than 2 hours. Because anyway, we won't be able to finish that module today. So before we begin to the content, as promised, we'll demonstrate the setup for the hands-on homework this week. And once we're done that, we'll get into the content. Alright, so our homework is here. You can find the link by clicking that assignment there, and in the description there's a link, and you should be able to find this GitHub repo. Same step for what I've done so far, fork it, and clone the code. So I've already had that. Let me move it to there. Try it again. And I got the code. Let me open the editor. Put the editor into the stream. 1 second. We'll get to the editor later. Okay. So, the first step, click the, can you see that tweet? Nope. Let me move it a bit. So there's a link down there. Just follow that link. It has the introduction saying blah 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 blah. Basically tells the goal of this assignment. So this assignment is Agile Iteration, titled Agile Iteration. Basically what it does is it goes through kind of everything we've talked about so far. BDD, TDD, reflection code, and some Java, even client-side JavaScript stuff. And then that kind of procedure, the entire life cycle of one iteration. So to set it up, same idea. So hopefully you've already have RVM installed by this point. Let me rearrange the window a bit. Hopefully you can see that. So you probably already have RVM installed, and then once you switch to this directory, hopefully RVM should already have the Ruby version switched for you. Here, like that's what I have here. It should be on 2.6.5. Next, since this application is also has something to do with the front end and the client side JavaScript, so we also need to have Node installed. It uses Node to compile the assets and all that. So NVM is similar to RVM. It's a version manager for Node. And what you will need to do is install the other specific version listed here. Let me see what version I have. So I have somewhat earlier, a newer version. So what I'll do is I'll just copy that command, actually paste it, and I've actually already have that installed previously. Yes, I have that installed when I tested it. So now we'll switch to that version by doing nvm use that specific version. Now I'm on the right version. Next will be installing Yarn. Yarn is kind of similar to Bundler for Ruby and basically manage the dependencies and packages. I should have that already installed. Let me see. Yeah, I've already have that. And when you first install that, probably you won't have that. So just follow this command to install the correct version. The minor version, I think it's okay to be different. So for me, it's 1.22.15, although it's specified like 1.22.4. Although you will need to make a minor change, I believe, somewhere. We will get to that later. So now install the dependencies. Bundler you should already have them bundler. If not, you can run that command gem install bundler to install the bundler, and run bundler install to install the Ruby gems, and same thing for JavaScript. Yarn install to install the Node packages. Here, because I have new version, so it says the version is not correct. Easy fix is simply modify the package file, look for yarn, change it to the newer version, which I have here, and run yarn install again. Now I should be happy with the version. Wait for it to completely install. Alright, so now we have all the dependencies running. Next, same thing, same step, run the db migrate to prepare the database. Then run db seed to seed the database with some default data. And let's see if it's up and running by starting the dev server. Go to your browser, open the page. So it will take a while because it uses Webpacker to compile the JavaScript. Okay, and then you should see something like this. And then there's a few other options, like for Webpacker. It's not that required, but it's recommended. Webpacker basically will compile the JavaScripts at runtime, so it's better to have both of those running. So in the documentation here, it says to use proc file or process. You can call it either process file or proc file. Actually, let me see. Yeah, it's covered. Okay, let me rearrange it a bit. Alright, so that's the last step for the setup. You don't necessarily need to do that. And then I don't think that's the easiest way to do it. The other way to do it is just run that in the background. So what you could do is do the command and then append it with an end symbol. It basically will send this command to backend, so it will be running in the backend. Or the other option, you could just start another terminal to run both commands. So here I just ran it in backend. Let's see that. Oh, what's that? Okay, so yeah, the documentation is not correct. So it should be called Webpack Dev Server instead of Webpacker Dev Server. So let's do that. So that should be running in the background. And then if you run the jobs command, you should be able to see that this command is running in the background. Alright, and then you can go back and start the Rails server. So this way you can have both the Node.js Webpack Dev server running in the background, and then Rails server running in the front. And then to stop it, you could just bring that to the front by running Pt.1. 1 stands for the job that's running in the background, the ID of the job. So, so you can see this one, the ID of this one is 1 up here. So just bring that to the front ground and then Control C to stop it. So now we have no background jobs. To learn more about background jobs for Linux commands, you could just Google it, Linux jobs or Linux background and frontground jobs. You should find enough information about that. Okay. So next, setup linter. These are pretty optional. I've actually mentioned that in the second week, I believe, where I talk about robocop for Ruby linked, and then there's another one for JS linked. And then here there are some extra linters for Haml, and then all the other stuff. These are optional, but you can run it. Next, if you follow the documentation, actually, let me rearrange that again. So here's the documentation. Since you're not going to be deploying it in production, so you can pretty much just skip the credential management here. You don't necessarily need it, although for this part, the development environments, you may want to change the Google Client ID and Google Client secret to make the application fully functional. Heroku you can totally skip. since we're not going to deploy it. Travis, you can skip it. It's actually pretty complicated to set up, especially given that it's a bit outdated. So we can skip that. But so we've been skipping Travis so far for all these assignments in this course, but still Travis CI is a powerful CI service. You could still try it out. What you can do is start with a fresh new Rails application, implement some very basic features, add some testing, and then you can try to set up Travis that way. And then I think that's more straightforward than kind of working with an existing, a bit outdated code base to set up Travis CI. Code cover for test coverage, that's also optional. You don't really need to do that. And pivotal tracker, you also don't need to do that. But again, feel free to test it out. As we've talked about that, I think 2 weeks ago when we went through 2-3 weeks when we talked about pivotal tracker. Right, and then it will be understanding the code base, give you some brief introduction of different tools, different stuff it uses, and then front end it uses Stimulus.js. That's a JavaScript framework. So if you want to figure out the JavaScript part, you may need to quickly go through that framework to have some basic understanding of how that framework works before you dig into the JavaScript code. And then when you click that, you should see a 404 page because they haven't updated documentation. So what you will do is go back to the docs folder by clicking the link up there, and then you should be able to find checkpoint 02.md. That's actually the instruction that tells you what you need to do. So here you can see part 1, 2, 3, overview, part 1, task 1. So that's what you want to do. So the first task is refactor the legacy code. Task 2 is to add some new feature. And part 2, task 4 is to implement another set of feature, and then finally improve the coverage by adding some more testings and blah blah blah. Alright, so that will be it for this assignment. So I've showed you how to set it up. Hopefully this is actually a pretty big assignment. So I will just have that for 2 weeks for whoever chose to do this hand-on project. Which means for next week there will be no bonus option or bonus homework option. Next week we will only have a basic option. So for the bonus option is basically working on this hands-on assignment. So this assignment is good for 2 weeks. Okay, so that's it about the assignment. Let me remove the terminal window. Close the pages, this page. Right, so now next, let's get into the content today. So we've finished the discussion about agile team, the workflow, the processes. uh, last lecture. So today we move on to the next module. If you look into the edX course, it will be module 3, which talks about design patterns. So before we begin about design patterns for students who are not that much experienced with programming and coding yet, then you may feel very difficult or challenging and confusing when we talk about design patterns, because really design patterns is based off of really quite a few experiences writing code, and then learning from mistakes, and that's actually how design pattern started, where a group of people decided, hey, this kind of code always gets messy. Is there any way to improve that? And then after a while, when doing that over and over again, they figure out some pattern that can better structure some part of code. So that's where design pattern comes from. So now then, in order to understand design pattern, you actually need to have quite some experience with programming. Otherwise, it will be really difficult to make sense of it. So if you feel confused, it's totally fine. Even for me, I've watched videos, read books about design pattern many times, and that's one of the strategy I apply when it gets to learning new stuff, especially learning tough stuff. It's just repeat a few times. For example, I've read 3 books on discussing design patterns, and then for the first book I read it 3 times. So yeah. So basically what I want to say is it's okay that you feel confused, and then if you feel you don't really understand what we're talking about for today or this topic, just leave it, because it depends so much on your experience. You actually could spend time learning other courses, do some side projects, your personal project, do some programming, and maybe in half a year or next year revisit this part again. And for me, it's the same process. Even after reading the first books 3 times, I won't say I fully understood what they were talking about. I understood part of that, but also at the beginning I was also limited in my experience. So it takes time to learn about design patterns, and even today I cannot memorize all the design patterns, but now I have a good enough understanding of that so that I can always just Google it and then look up whatever I needed for a certain part of code. Alright, so what I want to say, I want to encourage you, if you feel difficult to understand, it's totally fine. And then just in half a year, a year, sometime later, revisit again. And probably it will take at least 3 times, I think, to get some good hold of it. Okay, yeah, so that's all I want to say. Now we will just jump into the video. Okay.
In a previous module, we introduced refactoring, and the examples in that module focused largely on writing good methods by making each method short, do one thing, have few arguments, and stick to a single level of abstraction, a set of properties that you can refer to by the acronym SOFA. Well, in this module, we'll look at 5 principles regarding the relationships among classes in your application. And those 5 principles are summarized by another acronym, SOLID. Keeping in mind that Agile is about embracing change, the goal of these principles is to minimize the design costs and complexity of future changes that might be necessary to your code. To put those principles into practice, we'll make use of a variety of design patterns. A design pattern is a particular structure for organizing functionality and responsibility at the level of classes, analogous to how Model View Controller organizes subsystem functionality at the level of a whole interactive application. You can think of design patterns as the ingredients for building code that respects the SOLID principles. Now, depending on how you count, there are dozens of design patterns. Just as with architectural patterns like Model View Controller, most design patterns arose after developers had observed that many different solutions to the same problem actually shared quite a bit of structure. That structure was then identified and codified as a design pattern. But for that very reason, it's hard to learn design patterns by just memorizing a list of them, because often you don't know that you need one until you're looking at a piece of code that just can't be modified to do what you want without becoming really ugly. Sometimes we say that going ahead with such a change anyway would be an anti-pattern. But the fact remains, it's hard to just memorize a list of solutions without having first encountered the problems that those solutions are good for. For example, the active record associations we covered in an earlier module are a great example of the proxy object pattern, in which one object that has certain behaviors stands in for a very different kind of object that has those same behaviors. In the case of associations, the association object quacks like an array, but it isn't one. Leonardo da Vinci said, "Art is never finished, only abandoned." You might say the same about software. There's always room for improvement. And in the case of Agile, improvement means making the software more amenable to continued evolution and change. There are many entire books out there just about design patterns, but we hope that the approach of this module will help you get started thinking about software not as a static, unchanging artifact that you build and abandon, but as a piece of craft that there is always more opportunity to polish.
Right, so this module is actually originally the next module after, let me scroll up, after legacy code and refactoring, but for some reason they rearranged the order. So design pattern is really very much a continued discussion on writing buildable code and refactoring code. So yeah, please just keep that in mind. The principle is pretty much still the same, because the goal is still trying to make the code beautiful, maintainable, easy to modify, easy to understand. So with design pattern, we just get more specific in terms of certain patterns that we see over and over again. Alright, so that's just a quick comment over there. Let's get to the next video.
Hey, welcome back, everyone. I get the sense a lot of us are like a little lower energy today. That's cool. By the way, does anyone know what the image refers to? Anybody know the term that is being suggested by the image? Rubber duck debugging is correct. So for those, who's anybody heard of rubber duck debugging besides whoever? Cool. So I'm putting it up only to say this is not a good substitute for pair programming. Rubber ducks make much less dynamic pairing partners, but if you're in a situation where your pairing partner is not available, I've actually found some version of this approach to work pretty well. So for those of you who have not heard of rubber duck debugging, the idea is if your code's not doing what you expect, you sit your rubber duck down on the keyboard and you explain to your rubber duck each line of code. And the rationale is that forcing you to verbalize what you think each line of code is supposed to do and what assumptions you're kind of making when you wrote it will often be enough for you to reveal the bug to yourself. And I'm sure you've had the experience of, you ask a friend for help debugging, and as you start explaining what the problem is, you suddenly understand, like the source of the bug is revealed to you. So if you haven't tried rubber duck debugging, try it when your pairing partner's not around. Pairing is still way better, in part because if you're pairing according to the proper protocol, which means that as you're writing code, the person who's driving is explaining and sort of thinking out loud, and the observer is kind of cross-checking everything, that's actually the best version, because then you're likely to catch the bug sooner. Anyway, there we are. So we're going to continue today and next lecture with the theme that we started on Tuesday, which is how to make your code easy for others to modify, or as easy as possible for others to modify. So when we started talking about Agile, we said it's about embracing change and understanding that it's a fact of life, and it's one of the strengths of software, that if you can manage the change process, software has this great property that hardware doesn't have, which is after it's deployed and in the field, you can keep improving it. So the flip side of that is in order to make it tractable for someone else to pick up your code, you do have to go out of your way to make your code easier to understand. And that also includes, when you come back to your code in a few months, right? So we took a stab at starting on that on Tuesday. If we think of functions as sort of the basic building blocks that all code is ultimately made of, we looked at these guidelines called SOFA for writing good functions. They're short, they do one thing, they have few arguments, and they stick to a single level of abstraction. So today, we're going to try to apply some of that same kind of thinking, but at the level of classes. What does it mean to design a good class? What does it mean to design classes that interact with each other in a graceful way? And graceful, in this case, means trying to manage or mitigate the cost of future changes or future enhancements to those classes. So we're going to have a total of really 2 full lectures plus then some on design patterns. As most of you know, books and books have been written about them. So obviously, we're not going to cover all of design patterns in 2 lectures. But the goal is to get you familiar with the kinds of thinking that go into them and to get you into the mindset where you can see how to apply them in your own code. And design patterns I've always found sort of challenging to teach because it doesn't seem very effective to me to say, OK, here's a laundry list of good things to do. As you're coding, look for opportunities where your patterns match the good things and then use the patterns. In reality, what usually happens is you start writing some code, and at a certain point, the code gets out of control. It gets ugly in very obvious ways. And you know it's getting ugly because things happen like a change that should be simple ends up being complicated, or a change that shouldn't really affect anything outside of a single function ends up having these little ripply changes everywhere else. So sometimes we call those anti-patterns. And it's basically that is your code crying out for help, saying, is there a better way to do this, so that making those changes would not have been so expensive. So we're going to spend a couple of lectures looking at different ways to do that, but now at the level of classes. Actually, the original idea of design patterns doesn't come from software at all. It comes from the field of urban architecture. This book, a classic in the architectural literature called A Pattern Language, was a way of describing tried and true solutions to problems that occur over and over, not necessarily identical, but similar to each other in a particular domain. And in this case, the domain was urban architecture. So the architect, Christopher Alexander, identified over 250 architectural patterns that solve various kinds of problems in how you plan the layout of cities, how do you plan the architectural elements of different kinds of buildings. It doesn't mean that every single building is going to look identical, but that there are certain sort of approaches that once they've discovered to work well, you should try to reuse them. So pattern language is a little bit of a misnomer. It was, pattern language in the context of architecture is really a conceptual vocabulary for tackling these kinds of problems. It's a little bit tricky when we talk about software because when we say language, we tend to mean a formal notation that can be used for programming. So keep in mind, when we're talking about design patterns or when you hear people in the context of software talking about pattern languages, they don't usually mean an actual language in the sense of a programming language. What they mean is a collection of related concepts that help you sort of frame an approach to solving a class of problems effectively. And especially in software, the goal, which again comes from architecture, is how do you keep separate the things that might change from the things that probably will stay the same? Because if you isolate the things that might change, that is one way to mitigate the cost of change. So we've already seen some kinds of patterns in software. At the macro scale, we've talked about patterns that make up the way that application architectures fit together. So model view controller is a pattern, right? It talks about components that have specific responsibilities, the interactions among those components, and who does what. But it's not formally modeled in a language. So you might look at an application and say, aha, this application calls for would be a good fit for model view controller. And sure, there's frameworks like Rails and Backbone and so forth that you can take off the shelf that will kind of get you on the right path, right? They'll save you a lot of work, but it's not as if every app that is model view controller is going to be identical. So that gives you the sense of a pattern language. Other architectural patterns we haven't really talked about, but that you've probably seen. Pipe and filter, if you do a Unix command line and you separate things with pipes. Event-based, programs like games or even a web user interface where it sort of spends most of its time waiting for the user to do something, and it's not obvious what the user is going to do next. So the basic structure of the program is how do you respond to those events? If you've tried writing server-side code in Node.js, it kind of looks like that. It spends most of its time waiting for something to happen. And we can have a separate discussion later about why I'm not convinced that that's a good model for server-side programming. Layers, so if you look at the technology stack of software as a service or the networking stack of TCP/IP, the idea is that each layer has certain responsibilities and presents a certain abstraction to the layers above and below it. So a layered architecture would be another example. There's also patterns for computing things. If you look in scientific computing, there's all kinds of formulas and math problems that structurally share a lot of elements. So linear algebra, right? Matrix multiplication, Fourier transforms, things like that. And then the kind of patterns that we're primarily going to be concerned with are what some people in software call the Goff patterns for gang of four, after the group of four authors who in the mid-1990s wrote what is now considered the sort of seminal book on patterns from the software engineering point of view. And they divided the patterns that they identified looking at different software systems into three different kinds that they called structural, behavioral, and creational patterns. So this was the famous design patterns book, Gamma, Helm, Johnson, and Vlasides. And their goal was to really do for software kind of what Alexander did for architecture, to find patterns of the way that classes fit together or that classes do certain things and relate to other classes that came up over and over again in different software projects across a variety of domains. They identified a total of 23 design patterns, which we now call the structural design patterns. And what they're really capturing is the way that objects and classes communicate with each other, right? So kind of think of the same idea as model view controller, only now it's maybe at a finer grained level and will solve subproblems that would happen inside of a model or inside of a controller, for example. And keep in mind, a pattern usually does not mean a particular class. It does not mean that there's a library that just gives you the pattern. There are often libraries or frameworks that will help you, right, in the same sense that Rails will help you create a model view controller app, but the library or framework itself doesn't implement the pattern. It gives you some machinery, if you will, so that when you want to implement something using that pattern, it sort of saves you some of the common work. So think of it more like a blueprint for a design than the actual design itself. I am not going to do the thing that I think some courses try to do, which is actually to go through the 23 patterns in the original book. And by the way, since that book came out, other patterns and patterns that are sort of derivatives of these have also been identified. So a full list of design patterns is probably in the several dozens by now. And I don't think it's very effective to try to just enumerate them and keep your eye on the lookout for when you're supposed to use them. But the approach that we're going to take in this course is a little bit different. We try to show some actual situations that would arise in the kinds of projects that you all are doing, and in particular how, as the code evolves, it will lead you towards an anti-pattern. It will lead you towards a situation where you're doing something and you're making it harder than it needs to be because there's an existing design pattern that would make it easier, and using that as motivation, then we'll identify the patterns that come into play. So of the sort of 23, I guess, on this slide, we will look in detail at maybe half a dozen. And again, the goal is not that you become an expert in using all the patterns. It's to get into the mode of thinking of how those design patterns are intended to work. I mentioned the concept of an anti-pattern, which is code that looks like it probably should follow some design pattern, but it didn't. Most of the time, it's not because the person who wrote it had no idea what they were doing. It's because the code has accumulated over time more features and maybe more technical debt, right? Technical debt being making changes to the code that over the course of time serve to degrade its structure, even if it's still working, and in particular are going to make it harder to make changes to the code in the future. And probably you experience some of these symptoms yourself that will tell you if your code is creeping toward an anti-pattern. Using the terminology of design patterns, people, viscosity is when you know what the right thing to do is to extend your code in a certain way, but it's easier to do a hack than it is to do the right thing. Right? If your code was well factored, it ought to be easier to do the right thing. Immobility. We talk over and over again about the concept of dry. How do you pull out commonly used things and put them into a reusable module, whether that's a function or a class? If you can identify places where things almost seem to be similar, but they're not similar enough that you can pull out the commonality in a clean way. That's immobility, which is related to needless repetition. When things are similar but not exactly the same, you find yourself copy and pasting code and making small changes. That's a red flag. And needless complexity. So you start out designing something, and you're designing not only for the case you're solving now, but for some future case which may or may never occur, and that adds complexity that you may or may not ever use. So those are just a few of the symptoms that are a tip-off that maybe your code is not heading in the direction it should be. And in the early to mid-2000s, Bob Martin, so-called Uncle Bob and one of the co-authors of the Agile Manifesto and the Agile way of thinking about things, actually came up with a framework for what makes a good set of communicating classes. How should responsibilities among classes be parceled out? So what we're going to be exploring is the relationship between these 5 principles that they laid out and some of the design patterns that were identified in the Gang of 4 book. The acronym SOLID is used to refer to these, and we're going to go through these each one at a time, but there are 5 principles: single responsibility, open close, Liskov substitution, Demeter, and I'm going to give you a caveat. Usually the I in SOLID is for the interface segregation principle, and for reasons that will become clear when we discuss that principle, that one is less relevant in dynamic languages like Ruby, but dependency injection, which is super important, we're going to use the I to stand for that as well instead. So injection of dependencies is going to be our I. Right? So over the next couple of lectures, these are what we're going to look at. And again, the approach is going to be, let's show a real life example of how something could get to the point where one or more of these principles is being violated. And in that case, what are some design patterns that might be able to be applied that would remedy the violation? So that's where we're going. And in terms of comparing this to what we were talking about on Tuesday, in some sense, on Tuesday we were talking about what do you do at the level of individual methods, right? What makes a method good, and what can you measure about it? So we talked about code smells, which are qualitative aspects of code that can be an issue that tip you off that your code has some ugliness. There's also design smells that characterize classes that maybe haven't been set up the right way. In both cases, there are catalogs that will list different kinds of code smells and design smells you can look for, and refactorings that would help you fix them. There are metrics. We talked about assignment branch condition and cyclomatic complexity for measuring functions. We're going to talk about a couple of metrics, including LCOM, lack of cohesion of methods, that are a quantitative tip-off to one of the solid principles being violated. In both cases, there are refactorings that can help fix the structure of the code. We looked at some simple refactorings at the level of a function on Tuesday. So we looked at extracting methods, moving around code within a class. Now we're going to look at refactorings that maybe extract an entire class, or that move code from one class to another to fix some of the problems. And of course, each one has a handy acronym to help you remember it. And I defy you to remember those acronyms by memory, which means if there's an exam, you won't have to remember them by memory. We will give them to you. So what we're going to do is give examples of the solid principles. We're going to go through each one, show what it means, and show the circumstances under which you might find yourself accidentally in violation, and then showing which design patterns could help bring your code back sort of into more compliance or harmony with that principle. It is a non-goal, as usual, for you to remember all the syntax of all the examples. All the examples I'm going to do are on GitHub or in the book or both, but the goal is to understand the big idea of each of the principles so that you can recognize it when you see it.
Hi, so that's a kind of overview of what we're going to talk about for the next several videos. Basically, the only key takeaway is the SOLID acronym, which stands for all that. And then we'll talk about each of those in the next video. So I believe it will be, yes. Oh, actually, next video will be UML. Which is a pretty useful, handy diagramming tool that you will learn. I typically use UML. Actually, let's watch that video first.
So UML is really more like a set of types of diagrams than a language. It's not like a programming language, but it is a set of notations for describing various structures in an object-oriented system. There's a zillion different UML diagrams, but the most common kind, which we're going to use a lot, is the class diagram that shows the class relationships, and sometimes it shows some of the most important methods in the class. So what kinds of things can you put into a class diagram? So the open arrow is an inheritance relationship that says that car is a subclass of vehicle. It inherits from it. A solid arrow says that this thing is a component. So an engine is a component of a car. What does that mean? That among a car's various attributes, one of the attributes is an engine. In this, we've shown that a couple of the important methods of the engine are start and stop. You don't necessarily have to list a lot of methods here. I find that the diagrams get sort of pretty bulky pretty fast. So we can use them to represent relationships along the lines of the ones that we've been talking about, like has many and belongs to. So this is a somewhat complicated diagram, but it's actually not that bad once you unpack it. One kind of relationship is called an aggregation. That's usually an open rectangle, but I'm not going to take off points if you forget which one is an open and which one is a solid diamond, because I always forget myself. But basically this says this is a relationship in which the child can exist independently of the parent. So whatever an account code is, there's a mapping between one account code and 0 or more items. Okay, so if we said it another way, we could say account code has many items. Item belongs to account code. And the open diamond technically is supposed to mean that even if account code did not exist, it would still make sense for item to exist. The other kind is the one with the solid diamond. And about half the time I teach this class, I reverse which is correct. So that's why I'm not going to penalize you if you reverse it. Same idea. One of these has many of these. One of these belongs to exactly one of these. The difference here is that the solid diamond supposedly means that it doesn't make sense to talk about only the child in the absence of the parent. So in this case, the relationship is the customer has many items. An item is a thing that the customer can buy. But it doesn't make sense to talk about an item if there's no customer that bought it. So it's a subtle distinction, and I will never take off points on an exam for anything like that. But you may see both open and solid diamonds, and now you know. The more relevant thing is the numbers at each end of the arrow, which is the cardinality of the relationship. Right? One of these maps to 0 or more of those. One of these maps to 0 or more of those. One of these maps to 1 or more of those. Right? So here's a scenario in which if this thing exists, then it is guaranteed or it's necessary that at least one of these things exists, but there could be more, 1 up to asterisk. Excuse me. And again, an example of inheritance. In this diagram, whatever an item is, 2 things that are subclasses of it are donations and vouchers. So either of those has a strict subclass relationship. We'll talk a lot more about subclasses when we do solid class design. So, and by the way, this diagram was actually automatically generated for me. There's a gem that you can use, and I'll put it in the slides, that will essentially walk through all of your model files and database tables, and it will draw this. If you're working with legacy code and you're trying to understand which are the most important models, that could be a really useful diagram to have. So, by the way, these are all the different kinds of UML diagrams. We're not going to cover the other 85 kinds. I just want to be able to get it so that when we're talking about classes, whether it's active record models or something else, we can easily talk about the relationships between classes. So why does this much matter? This matters because we can now sort of introduce a sort of really low-cost way of thinking about the design of your app at the level of classes. And not every class in your app is going to be an active record model, but a lot of them probably are, because the models are the entities the app manipulates. It's kind of where most of the action happens. So to do that, we're going to introduce this really simple mechanism that, again, came out of the Agile movement called CRC cards for class, responsibility, and collaborator. And the idea is really simple. For every class defined in your app, whether it's an active record model or something else, you should be able to answer 2 questions. What are the things that it knows? And what are the things that it's responsible for doing that it might have to collaborate with other classes on? So this is an example based on the previous slide where we could say an order is a class that knows how many tickets are in it, but that implies that it has to collaborate with some other class that maybe is called ticket. An order knows how to compute its own price. That doesn't sound so bad. An order knows who owns it. Oh, sorry about the duplication of that line there. An order knows who owns it, but that implies that there must be a class representing a thing that can own an order, so we're going to call that patron. Similarly, a ticket, well, a ticket certainly knows its own price. It knows which performance it's for. OK, well, that implies that there is some class somewhere that models the concept of a performance, so ticket would have to collaborate with it. It knows whether it's available, is someone sitting there, and it knows if someone is sitting there, it knows who the patron is. So again, it implies that there is a class representing what the owning relationship is. And one way that you can come up with these, so the idea is that each one of these cards will probably map to a model in your app. And whenever there's a collaborator, that suggests that there's going to be some kind of relationship, like has many or belongs to, between those different models. Maybe it'll be a relationship that ends up going through a third class, like those many-to-many. So this is sort of an intermediate step before you define classes to say, which classes do I actually need, and which ones are going to have some relationship to each other. So how do you get to the point of even being able to draw this? Well, you could just sort of sit down and try to do it, but we found that an easier way to do it is to start from the user stories that you already have. So for example, if one of your user stories was something like this, adding movie tickets to a shopping cart, so as a patron, so that I can attend a showing of a movie, I want to add tickets to my order. Basically, go through that three-line part of your user story, identify the nouns, and identify the verbs. Nouns are probably models or relationships between models. Right? So for example, there's a ticket and there's a showing. OK, those are clearly models. Are those models related to each other? I don't know. Maybe there's an intermediate model. Because a ticket, I don't know, if a ticket could be valid for many different showings, but a showing has many tickets, maybe there's an intermediate model relationship. We're not sure. But tickets and showings certainly are things. And there's probably going to be a relationship between them. Verbs tend to be things that one of the models is responsible for. So as a patron, so that I can attend a showing. Attend is a verb. So somewhere in one of the models implicated in that statement, there's going to be a method that means make it so that this ticket is set to attend or be valid for that movie. Similarly, I want to add tickets to my order. Well, that implies at least three things. Tickets are a thing, an order is a thing, and adding tickets to an order is a thing. Now, we haven't said who is responsible for adding tickets to an order. Is it the case that you have the order and you give the order some tickets and say add these? Or is it the case that the ticket can support a method that says, here, add yourself to this order? We don't know. We haven't gotten that far. But this helps you identify what the main classes are likely to be. Right? Roughly speaking, nouns will probably end up as classes. There may be additional classes that model relationships between those nouns. And verbs will end up as method calls in one or more of the classes that actually make the things happen. So this is not a foolproof way. You're not going to get 100% of your classes and methods out of this. But it gives you a starting point. And it gives you a starting point that is based on a document that you already have, which is the user story. What do your colleagues have to say about this approach to app design? Again, this is from our top 10 list. This was number 2. Actually thinking about this stuff before you sit down and start writing code and creating migrations saved a lot of pain. That if you actually think about this stuff carefully, you can separate out your models nicely. We had a couple of teams where there was a team designing a client piece and a team designing a server piece, long story. But being able to figure out the division of responsibilities using this method allowed each team to sort of proceed in parallel without stepping on each other's toes. And the teams that hadn't really thought about this ended up wishing they had, because what happens if you don't design the object model properly is you find yourself having to implement some user story and there's no place to put it. There's no place for the functionality to live. The user story says, the user can do A to B, but you don't have an A or you don't have a B, and you have got no place to put the functionality of doing A to B. Does this mean that if you design your object model thoughtfully in iteration 1, you will never change it again? Almost certainly not. You will almost certainly end up evolving the model as you go, especially if the user asks for more features or more functionality later on that were not foreseen when you did the first round of planning. That's OK. You do the best that you can with the information you have. but spending some time to actually draw the little pictures, you could actually use little index cards to do the CRC cards. And then when you have gone through all of your user stories and you've got no cards left to add, or you've got no responsibilities or collaborators left to add on a given card, then you're done, right? At that point, you have enough functionality and enough class relationships to implement that set of user stories. So that is what I would suggest you do.
All right, so that's about UML and CRC card. I personally never use CRC card, so I don't have comment there. But for UML, typical use cases, I use it to visualize a database schema. So UML can be used for to represent a relational database schema. There are actually automated tools to convert stuff back and forth. And some of the database management tools actually have that like automatically converted, and then you can edit. So it's kind of just two different views. You can view the database as tables. You can also view it as UML charts, and then it allows you to edit either way. So that's one of the use cases. I use that quite a lot, especially when it gets to refactoring or legacy code. When you try to understand the database structure of a application that somebody else wrote, especially when it's complicated, then Rails has a gem that automatically converts DB migrations, the DB schema, into UML charts. That way you can visually see how different tables relate to each other, and it's really helpful to understand the data structure. And the next use case would be to design the models if it's a Rails application, or not just Rails, just any MVC application. Because typically, there's argument on there, but as for Rails, the idea is to have simple view and simple controller. Logic should be in either model or helpers or concerns, that kind of thing. Which means when we design the logics, the classes, the primary focus is actually within the models. So I sometimes use UML to design the models, especially for a new project, when there's a new project to be launched, and then when it's fairly complicated, then I use UML to design it, to figure out what kind of interfaces we need for each class or each model. The third situation would be an application that's not necessarily web application. Like once I wrote a game, and I also was another case, I forgot. Anyway, I've developed a few applications that's not web application. So it's not MVC. It's it's not structured in a way that usually SaaS application structures it. So then I would design the entire application, figure out different classes using UML. So yeah, UML is a pretty powerful tool. Typical use cases to visualize the database structure, to design the models if it's a Rails application or a web application. Also, there are different opinions. So if you don't want to have heavy models, I personally don't agree that would be a good practice. But if you want, that's a choice. But anyways, if it's, most of the logic is in the models, then UML can be used to design the models, and then it can be also used to design an entire application um, if you okay. So that's UML. And then when we talk about several examples for the design pattern, we also use UML to describe the relationship between each class. So you will see some of that, but it should be fairly easy to understand. It's pretty intuitive, I would say. So, okay, next video.
Okay, so we'll start with single responsibility, which basically is, to me, this is kind of related to functions should only do one thing. This is the class level expression of that, which basically says a class should have exactly one reason to change. And we talk about an axis of change of a class as being a responsibility. And the idea is that changes to one axis shouldn't affect the others. So a rule of thumb is if you can describe in sort of 25 words or less what is the one thing that this class does. If you remember when we talked about CRC cards as an aid to doing design of your different classes and identifying what the models in your app were going to be, what responsibilities they would have, that's actually pretty closely tied to this. You should be able to sort of, on an index card, write down what is the thing that this class is responsible for, what is the type of entity, and what are the operations that that entity has to know how to do on its own, and what are the things that it has to collaborate with other classes in order to do. And a tip-off is models that have many sets of behaviors. And this is actually a big pitfall in applications like the ones we're building, because the natural starting point for model view controller apps in software as a service is the logic goes in the model. And it is a very slippery slope for a single model to start accumulating all sorts of cruft. For example, almost every app that is being built by the projects in this course has some model that in some way represents who the user is, right? Because most of us are building apps that are user-facing. So following our simple example, we had the movie reviewing app, so a moviegoer is a user, but it's also an authentication principle, right? How do you determine who's logged in? Well, the idea of logging in isn't really identical to the idea of a user. In fact, there's a lot of sites that let you log in with a username and password, or they let you log in with your Facebook or GitHub credentials. So it's immediately pretty evident that the concept of logging in is not intimately tied to the concept of a user, but it's close enough that they tend to end up in the same model, right? Because if you're asking yourself, where should the logic go, that seems like a natural starting point. And then if you add the idea that, well, users in my app can have friends, so they can have sort of a little social network within the app, now there's the concept of the user having a friendship. But again, the friendship is a functionality that is defined by its own set of behaviors that maybe is different from what the user-specific behaviors are. So probably this is the principle that apps in this class are most likely, if you're not careful, to find yourself violating. Because there's a temptation to sort of start putting all of your logic into a small number of models, even if the logic is not sort of intimately tied to what that model is about. And you can measure this. So lack of cohesion of methods, which is, again, one of the many great metrics that Code Climate computes for you. The intuition here is basically if you have a certain set of instance variables in your class, and you have a certain set of methods in your class, then if the class really and truly has only one responsibility, it should be the case that most of the variables are touched by most of the methods, right? So if the class really only does one thing, and the different methods are sort of facets of handling that one responsibility, it stands to reason that most of the state associated with a class instance is going to be needed by most of those methods. If, in contrast, what you find is that when you sort of draw that graph of which methods in the class touch which variables, and you end up with sort of little sparsely connected components, that's a sign that there's actually probably more than one thing happening in the class, that you can actually separate out maybe into a couple of different classes, and you might be violating single responsibility. And by the way, a lot of these design principles, again, there isn't sort of a magic value of ALCOM above which you're a violation and below which you're in compliance, right? Like all of these metrics, these are intended to sort of guide you in the right direction. There was a debate for a little while in the Rails community about active record. And the debate was active record is bad because as a class, meaning the class from which your models inherit, it actually violates SRP. Why is that? Because whatever your active record model might be, users, movies, whatever, look at all the things that it knows how to do. Models can load, save, and delete themselves in the database. There's all this machinery about associations. There's the machinery about validations. And that's all in addition to whatever your model is supposed to be about. I actually don't really buy this argument because in some sense, these are behaviors that get mixed into the class, right? The idea of associations is not specific to any one active record model. It defines really something that's more like an interface and a set of behaviors that can be added to anything that behaves like an active record model. So when I think of a model in this case, I think of the thing that your code does and not the additional mixed-in mechanisms that active record provides to make it easier to represent that as a database stored model. And in fact, if you look at the way active record is authored, if you look at the source code, all of that stuff is actually included as modules. It's not really part of the base class. So I actually don't buy the argument that active record violates SRP. But what would? Here's a simple example of a sort of a way that even in a simple class, this can creep up on you. And I have a hypothetical customer class that, there we go. Didn't realize that there was that much animation. If a hypothetical customer class, customers often have an address. It is worth asking the question whether behaviors related to the address actually belong in the customer class or not. Even if it's the case that there is no other type of model that you have that has the concept of having an address, you could argue that things like validating a zip code or canonicalizing a mailing address, those are not things that are about a customer. Those are behaviors that can be isolated in some other class. So one way that you can address something like this, do you see what I did there? Come on, wake up. Give me some love. One way that you can address something like that, thank you. I'm here all week. One way that you can avoid this problem is instead of putting all the behavior in the customer class where it would go by default, suppose we pull out a separate class and we define some methods on that class. In fact, we can actually tell the address class that whenever somebody tries to call any of these sort of address-specific functions, we can actually define those methods back in the customer class and delegate them back. So what does that mean? It means that the abstraction of what happens to an address can be encapsulated in its own class, but that class doesn't have to always implement the functionality. And this is an example of composition and delegation, which is, if there's sort of an underlying meta pattern in the solid principles, it's that inheritance usually isn't the best way to solve the problem. If what you want to do is compartmentalize and reuse behaviors, it's better to compose, meaning that now, because the address logic is in its own class, but it's delegating these accessors, you can still have the benefit of storing all this stuff in the customer's table. So notice the difference, right? If you look at the customer's table schema, in the table, customers will have a zip, a street, and all of the other stuff. But the logic that is associated with how those things are manipulated and computations that really have to do only with them can get pulled out into a separate class. From the point of view of changing the code, that behavior can now be separated out. And there's actually a facility in Rails that helps you do this. Right? Oh, and by the way, we have drawn some class diagrams before, but now we're saying here's our base class, our customer. It inherits from active record, as we've always done before. But now, when a customer has an address, when that customer is, what we want to have happen is when the customer is loaded into memory from the database, we actually want to have one attribute of the customer be an instance of this other class that has its own methods and that can manipulate all of, it can do computations related to the address, but all the while, the actual values, the underlying fields of the address will still end up being in the customer's table. Right? So how do we do that? There's actually a really nice mechanism called composed of, which I'm not going to show the code for the example, but if you have cases like this, it's easy enough to look up. But the idea of composed of is you can say the customer has a field, address in this case, and address is its own class. So the accessors for things that are stored about the address, that's still part of the customer's table. But Rails will arrange that when the field gets loaded from the database, this will get set up automatically. So if I say that my customer is composed of an address, and I tell Rails what the attributes of the address are, then anytime I load a customer, it will automatically arrange for it to be the case that the address attribute of that customer gets initialized to a new instance of the address class. The instance of the address class has the correct attribute values that came from the customer's table. And conversely, if I make changes to these in the instance of the address class, then when the customer is saved back, all of the right things will happen. Right? So again, active record provides a way to get between the representation we want to have in memory, which is address is just one component of a customer, and it's an instance of a different class, even though in the database, the information that is related to an address will actually be stored along with the customer. So separating out a little bit the representation as we store it from the representation as we manipulate in memory. Okay? So this is a relatively simple example, but the point of the example is to show basically that even if the reason that you use models is because you have to store stuff. And when you have to pull out a class in order to avoid having one class doing too many things, you don't necessarily always have to create a separate table for that class. The idea of creating the class but delegating the storage of its attributes back to the containing class is fairly natural to do, and so Rails gives you a mechanism for it. Summary of the single responsibility principle. What did we say? It says that a class should have exactly one responsibility. That means it has only one reason to change. Going back to our simple example, the thing to understand is if we decide to change something about the representation of the address, or we decide to change, how do you compute whether an address is valid or the zip code's valid, those changes now do not touch the customer class at all. If we add attributes, like maybe we will even add new fields to the address, and that will result in a change to the database schema if we're still storing that stuff along with the customer model. But the customer class itself no longer has to change. Tests related to the customer class will not have to change. So isolating the things that change from those that stay the same. How do you know if you might have this problem? If you have a high LCOM score, or quite simply, if you have a long class. If that class file .rb includes a couple of hundred lines, it's very hard to argue that it's really only doing one thing unless that one thing is really complicated. And in particular, if you can, sometimes you can sort of visually identify groups of methods within a class that seem to rely on each other, but don't really have much of a connection to the rest of the class. So that's a good example of when you might be in trouble. What can you do? You can extract a class. That's by far the most common thing to do. There are other methods that include pulling reusable behaviors out into modules and things like that. That's actually how the active record library kind of got started, is that if you find yourself building over and over again adapters that allow you to store stuff in a database, you'd say, well, can we pull that set of behaviors out and mix the behaviors into any class we want without any knowledge of what the attributes are? So that's the idea.
All right, so that's SOP, or single responsibility principle. Later we will talk about composition over inheritance. I'll address more when we get there. But otherwise, the idea is just keep one class, do one thing, right? And also, my opinion, some people may disagree, one class per file. So then when you look at your code base, you know that, okay, if I open a file, this file should have only one class, or it could have like 1, 2 extra classes. That's fairly simple, and then modifies or enhance that class. But generally speaking, have one class per file. Then when you open that there's only one class, and then it should be single responsibility. As a result, that file shouldn't be too big. Reasonably, it should be within no more than a few hundreds of lines of code, right? If it's single responsibility. If it goes over that, it's like 1,000 lines of code, probably you need to ask yourself, is that class single responsibility? But anyways, by complying with this principle, I'm gonna have code that's very in a reasonable size for each file, and then it should be very well organized. Although it's easier said than done, for Rails it's typically easier because Rails already have those file structure laid out for you, and then it has all those auto loads, loading other files that's already done for you, so you don't need to do that. For other frameworks or other languages, for example, Node, and then one of the popular one is Express. It doesn't come with all this good stuff. It doesn't come with a file structure layout for you, so you may need to arrange it yourself. Otherwise, you might end up with a pretty messy file structure, and then maybe mixing multiple classes in one file. And it's not too bad, but just in my opinion, it's less readable. Um, so yeah, so that's about single responsibility. And then the other argument people may make is just, for example, the active record. That class actually does a bunch of stuff. So it actually makes sense to have, classes like superpower classes, which does all kinds of stuff. And at some point, there will be these kind of classes. But when you really look at it, the class itself is really just a composition of multiple components. The class itself really just assembles all these functionality, and then each individual set of functionality is implemented in their own classes. So from outside, a class may look very powerful, may look very complicated, may have many interfaces, and may do a bunch of different stuff. But if you look from the inside, it's actually split it up in different components. So I kind of agree with what the professor says here. Some may argue active record violates SRP, but actually it's not. It's just from outside it looks like that way. But as long as you are not the maintainer of the class, then it actually doesn't matter, right? And then if you're the maintainer or the developer or contributor of that class, that module, then you're looking from inside, then it actually it's still broken up into different pieces. It's still good in terms of SRP. So then another way, when you design your code, your classes, if it's a class that's supposed to be external facing, maybe it actually doesn't matter that much when the class have many functionality combining it. Although still the implementation should be single responsibility. That class should then still be the composition of multiple modules. Each implements a single responsibility. Right. So it actually makes sense to have classes that looking from outside, it does multiple things. Looking from inside, it's actually composed of different classes. So we'll talk more about composition. Just want to bring to your attention that single responsibility doesn't mean that every single class would just do one thing. At some point there will be classes that do multiple things, but it's just from the external point of view. When you actually look at the implementation, it should just still be following the SRP. Okay, so that's that. We'll move on to next.
Move on to the O in solid, and we're doing really well here on our progress. So the O in solid is for open closed, which basically means, again, in terms of changing minimizing the cost of change, that classes should be open for extension but closed against modification. And in particular, because we're using a language that isn't compiled and it's harder to see those changes, we're going to say closed against modification of the source code. So here's a motivating example to show how this might arise. In my hypothetical app, I have a facility for doing reports, and I have a method that will output whatever the report is, and somewhere in the user interface, the user is allowed to choose if they want to see an HTML or PDF formatted version of the report. So immediately, almost any time when you see a case statement of this kind that is basically dispatching to different subfunctions, this is already a yellow flag, because there's no way to add new types of reports. Like if I now decide that I want to add, besides HTML and PDF, I also want PostScript or something, there's no way to add a new report type without changing the base class that contains the report. And that doesn't make any sense, because adding a new report type should not involve changing the existing report types, right? It's strictly adding new stuff. So the goal of open-close is make it so that adding new stuff doesn't require retroactively changing an existing class. One of the reasons that it's easy to fall into this pitfall in interpreted languages like Ruby and Python is if you were doing this in a compiled language like Java, and you had a report class that kind of looked like this, and you wanted to add a behavior, meaning that you need to modify by adding another case clause here, now you have to recompile the report class to do that. And everything that depends on that compiled class is eventually going to have to be rebuilt. And that's a penalty that you don't have to pay in an interpreted language. So sometimes the pain of doing this is a little bit less evident. So it's not as bad as if you do it in a statically typed language. But it's still ugly that adding new kinds of stuff requires you to retroactively change other kinds of stuff. So that's the code smell that you're looking for is essentially having something that dispatches on one of multiple possibilities, and you know that in the future it's probable that you might want to add more possibilities to the list. So how do you fix this problem in practice? We're going to use sort of a combination of 3 different things, and that'll give us the opportunity to look at a couple of different classes of those gang of 4 design patterns. And here's the game plan that we're going to follow. And again, remember, part of the challenge here is we don't know the report type that's going to be desired until the actual runtime, right? Until execution time. So we're going to do 3 things. First of all, we're going to use one of the construction patterns called abstract factory, because that will allow us to, at runtime, create an instance of a class where we don't know in advance what the class name is going to be. And it turns out that because of the way Ruby handles metaprogramming, it has a really elegant implementation of how we're going to do that. Once that's in place, we're going to essentially apply one of these 2 choices that they're very related. Template method is one, strategy pattern is the other. They address a similar thing, which is there's a particular task you want to do, but there are variations in how that task might be done. So applying either template or strategy will give us the machinery so that now when we add new variants of how to do it, we will not have to change the base class anymore. And finally, we're going to do like an additional bonus trick, which is that we're going to realize that once we have the ability to add new formatters, actually it's going to become appealing to have formatters that are stackable. So not only having a report that's, let's say, encrypted, but also password protected. And how do you sort of add different options without having an inheritance tree from hell? So we're going to do these 3 things in this order. And the first one is, in some sense, perhaps the easiest. And we're going to do a little before and after. Okay? What I've got up here is basically the code from the previous slide. This is the code that pretty clearly has the open-close problem, because these 2 one clauses are the only 2 ways to dispatch. And what we were basically doing in this case is we're assuming that the class has an instance variable at format, and that the value of that instance variable, which we're assuming is going to be either HTML or PDF, is going to tell us what is the class of the actual formatter that we want to invoke. Here's a nicer way to do it at the bottom. Again, don't worry about the syntax here. You can look up the syntax. But what the syntax is trying to do is say, take the value of this variable as a string and look up if there exists a class whose name is that. This is one of the neat Ruby metaprogramming things. You can pull this kind of trick off in Python as well. It's much harder to do this in a statically compiled language. But basically, if this statement succeeds, then the value of formatter class will be an actual class object like HTML formatter or PDF formatter. Right? So the assumption here is at format still tells us which class we want to use, but we have to have its value essentially spelled just like one of the existing classes that implements a report format. Because once we have that, we can send to that class the message, create a new instance of yourself, and boom, there's our formatter. So you can see, and let me pause for a moment, because it makes your brain hurt when you look at this if you haven't seen this kind of metaprogramming before. Okay? But again, just to review, what's going on is format is still supposed to tell us which type of formatter we want, but now we're going to ask Ruby to look up the class whose name matches that, and then we're going to tell that class, please create a new instance of yourself. That's my formatter object. Formatter is now an instance of the correct kind of thing, even though we didn't know at the time of writing this function what value at format could be. And of course, I've got a rescue clause, because if format is set to something like foobar, and there's no such thing as the foobar class, then when we try to do this, somewhere in here an exception is going to be raised because the class doesn't exist, and that lets me capture the exception and report back to the user, I don't know why, but @format is set to something stupid. Okay, so any questions about how this part works? I should say, what questions do you have about how this part works? Because the first time I saw code like this in Ruby, I was frankly confused. And I couldn't think of a good clicker question, so I'm going to rely on you to sort of speak up and say, that made no sense to me at all. What clarifications may I offer before going on how this piece works? No? OK, you're all with it, or all great. So this is an example of what's called the abstract factory pattern. Why is it an abstract factory pattern? Because you don't know at the moment you create the class, or sorry, at the moment you're writing this code, you don't know what possible value this class is going to be. You just know that at runtime, this variable @format is going to tell you that. So it's basically, I need to create an instance of a class, and the class is going to be somehow determined by something that's an input to this function, right? So this is Ruby's very concise, in my opinion, implementation of abstract factory. So that was step one, right? Now we have a way, and by the way, I think you're going to believe me when I say this now. If we now decide to add PostScript formatter, and we create a new class called PostScript formatter, then no changes are required down here. Because if this comes in with the value of @format being PostScript formatter, then this will just work. And if it comes in with that value and we have not defined the PostScript formatter class, then we'll throw an exception and handle it and say, sorry, there's no such thing as a PostScript formatter. So hopefully you believe me that by the end of this step, we're at the point where adding new possible report formatters no longer requires modifying the report base class containing this output method. If you believe that, then the next step is to figure out what mechanism we're going to use so that as we're adding those new varieties of classes, there's kind of a standardized way to do it that allows the report base class not to change. And there's two different approaches that let us do this. One is called template method. The other is called strategy. And really, the difference between them is in the template method, the set of steps for doing it is the same, but the implementation of the steps might be different in different variants. And that means that in general, you can use inheritance to implement it pretty gracefully. So for example, I'll show an example using the code from the previous slide. There we go. In contrast, if the task to be done is the same, but the specific sequencing of steps might be different in the different methods, then the strategy pattern is a little bit more general because it makes fewer assumptions about the internal structure of each of the variations. The trade-off is that the implementation is a little bit more subtle because you don't just get to use simple subclass inheritance. So I think the easy way to understand this is let me show how each of those two alternatives could be applied in our ongoing example about report generation. If we were doing the template pattern, we're basically saying, in the future, we might add new types of report formatters, but we always know that any report formatter is going to do three things. It's going to output a title, then a header, and then the report body. So no matter what other formatters we add, this is basically the structure that they're all going to have. They're only going to be different in the implementation of the methods that do each of the steps, but the sequencing of the steps will be the same. So this is pretty easy to implement because now, if report is our base class, we can just create subclasses of it that override the individual methods. Right? That's all there is to it. So if the sequencing of steps across different variants of the task is always going to be the same, this is probably the most straightforward way to do it. And the only machinery required is you're just doing inheritance from a base class. But there's a lot of situations where this is not sufficiently rich. Oh, by the way, if you care about doing these class diagrams, this is what the class diagram looks like. Right? Here's our base class. These are both inheriting from it. And the inheritance just allows each of the subclasses to do whatever specific thing it wants to do to override these generic methods. In the purest case, these methods are abstract, or I should say this class is abstract. And if you're using a compiled language, you can actually say the report class itself cannot do any of these things. These are purely virtual methods or purely abstract methods that must be overridden. In Ruby, you can't. There's really no way to say that. So what some people will do is that in the base class, they'll define these three methods, but the methods will raise an exception saying, I should never be called, because the reality is some descendant of me in some subclass is what should be called. Okay, so that's what this looks like. This is the simplest possible way to do it. what about cases where this doesn't work because the sequencing of steps is not necessarily the same? Maybe there are some report types where these are not the same 3 steps, or where they're not done in this order, or where some other thing has to be done. So the more general version of this is the strategy pattern, which basically says the report base class is not going to have descendants. Instead, one of its attributes is going to be a formatter object, and that formatter object may have some subclasses. But I don't really know anything about how the formatter object works, right? So when someone calls output report on an instance of the base class, all it does is delegate that call to one of its subclasses, right? So when we did the abstract factory pattern, we showed how you can arrange for the report's formatter to have the correct class at runtime. Basically, the report is saying, the only thing I know how to do for output is essentially forward that request to whichever formatter was chosen. And internally, I have no knowledge of what it does. There's no assumption that all formatters would work the same way. And on the next slide, we're going to see if you end up having to do it this way, there's actually another nice benefit that you get. So there's this general principle that says when you're trying to isolate things that change from things that stay the same, yes, it's true that when you're using subclass inheritance, that is one way to reuse behaviors. But there's a number of different issues that come up. One of them, which we're going to talk about in the next solid, which is Liskov substitution. But also, it's pretty rigid, right? The inheritance actually makes a lot of assumptions about the similarities between a base class and its subclasses. Here, we're not really making any. We're just saying the report knows that it has a formatter associated with it. And when it's asked to do something, all it does is delegate it. It forwards the call to that formatter without any assumptions about how the formatter is going to do its job. So let's see what else you can use this for. Because, continuing the motivation of our example, imagine that we want to enhance the PDF formatter in the following way. As you may know, a thing that you can do with a PDF file is that you can protect it with a password. Another thing you can do with a PDF file is you can watermark it. It's the equivalent of having those, draft, do not reproduce. And in fact, you could have any combination of these features on a PDF file. So suppose you wanted to expose something like that. What's the right mechanism for doing it? Because if you try to solve this with inheritance, you start to run into a problem, right? We already have the plain old PDF formatter, but now we need a PDF with password formatter, a PDF with watermark formatter, and a PDF with password and watermark. And if the order in which they're applied matters, then actually we would even need another one, which is a PDF with watermark and password formatter. So you start getting an explosion of behaviors, right? And it smells bad to sort of try to make a separate subclass for each of those. So inheritance doesn't solve this problem particularly well, but the previous approach, using the strategy pattern, actually can solve it quite nicely in the following way. And I'll show the source code for this in a moment to help you walk through it, but conceptually, here's what's going on. We have an existing PDF formatter, but we're going to define these additional classes that we say decorate the behavior of their superclass. So what does it mean to decorate a superclass's behavior? It means that each of these subclasses will have as one of its components a copy of the object to which it belongs. It has specialized behaviors that it knows how to do, like adding a watermark or protecting something with a password. But the thing that it returns as a result of those behaviors is an object that is compatible with the base class. And again, let me show the source code will make this a lot easier to understand. So let me show you what that looks like. Okay, now we're getting, this is like good refactoring software engineering stuff. So what do we have going on here? At the top, here's our generic PDF formatter. The only thing it knows how to do is it can be one of the kinds of formatters that you'll delegate a call to, and its output method will get called. Now let's decorate it. To decorate it with the ability to do passwords, notice that although I'm inheriting from the superclass, my constructor is different. In particular, when I construct an instance of PDF with password formatter, it is expecting to be passed a copy of the class that initialized it. Because then, when I call output, basically what I'm saying is, when I am called upon to do to add a password to a file, the first thing I'll do is I'll call the output method of my base class. That's this method up here. Then I will protect that thing with a password, and that's the thing that I return. So I'm essentially delegating most of the work to the class I inherited from, but I'm doing my little special bit of magic on top of that basic work, which is where the name decorator comes from. Let's do a different decoration. Same idea here. PDF with watermark formatter. When I am called, I will retain a copy of the object that owns me. And when I'm called to actually do some work, I can first delegate most of the base work to be done with my original class, with the object that owns me. And then I will add my little special function of watermark on top of that. And what's really nice about these is that they can be stacked up, right? Because I can create a new PDF formatter. That was the basic one we already had before. And now I can create a new PDF with watermark formatter that takes as its constructor argument a regular PDF formatter. So these two classes have the same class signature, right? PDF with watermark formatter is a subclass of PDF formatter. So anywhere that it's legal to use one of these, it is legal to use one of these. We'll talk about that more in detail later. That's called Liskov substitution. But intuitively, I think you get the idea, right? Every instance of PDF with watermark formatter is also an instance of PDF formatter. So, but now, once I have this formatter, I can actually also stack it 3 deep, because anything that is a valid subclass of the base class can be passed in as the constructor. So now I can start with a PDF formatter, decorate it with password addition, and decorate it again with watermarks. And the thing that I still have, the formatter, is still something that could be called anywhere that PDF formatter could have been called. So from the point of view of who's doing the call on the formatter, it behaves the same way. It has an output method, but I can stack the decorators in any order that I want. Right, so that's kind of how the source code looks for an example like this. And we say that these classes decorate the behavior of a class that is Liskov compatible. In a few minutes, we'll talk about Liskov substitution and what that formally means. So, by the way, you may have already seen this, depending on how much complex code you've written in Active Record. If you've used Active Record scopes, or even if you remember some of the simple Active Record examples we did at the very beginning, that you can define a scope like for kids, which basically translates into where rating is G or whatever we said it was. And you can define a scope like with good reviews, which looks for a movie whose average review score is whatever. And now you can actually stack all of these. You can chain them in the calls, right? You can chain the where calls. So this is actually an example of doing decoration, where you can create scopes that decorate the basic behavior of the active record relation, and then you can stack the scopes as long as anytime you stack them, the stacking observes the fact that any one of these could have been legally called wherever you expected a movie. So if you can call where on a movie, it has to be possible to call where on whatever is returned by for kids, and it's got to be possible to call where on whatever is returned with good reviews. But if you maintain that, right, and that's kind of what we did in this example, all of these guys have an output method, but they expect to be able to delegate some behavior to their containing class. If you can get away with that, then you end up with these nice stackable decorators. So we've sort of applied 3 different mechanisms here. And again, inheritance plays a role, but the more important role is the one played by composition. Right? Composition just means one of the components of some object is an instance of some other object to which some work is going to be delegated. So a careful use of this stacking, right? Again, what were the 3 things we did? We made it so that the abstract factory can be used to create the correct class of thing at runtime. Now we don't have to change the report class anymore. Then, using either the template method pattern or the strategy pattern, we defined what the interface of any formatter has to be. It has to have this output function. And then finally, if in fact we're using the strategy pattern version, we can also take advantage of the fact that we can define subclasses that do decoration and then are stackable on top of it. Right? So that's, I kind of like this example, even though it's a little complex to get your head around, because it illustrates 3 different design patterns at work. Right? There's the abstract factory pattern, the template pattern or strategy pattern, whichever one you use, and then the decorator pattern. And they're all sort of put together in the service of solving what is a realistic problem. So in practice, right, open-close says don't make it so that classes are closed against modification. And the problem is that that sort of simplistically assumes that you somehow know in advance all of the types of changes you might someday want to make. And of course, that's an ideal, but in practice, you don't necessarily know. There's no real magic bullet. Sometimes you'll find yourself in a situation where you just did not foresee that there was a particular way that you wanted to extend a class. Right? When you create examples for instruction, you can always create an example where it makes sense to say, well, yeah, of course, you might want to add new report formats in the future. But what if what you really need to add is within the PDF formatter, different printer types or character sets? There isn't really anything in the interface we described that would make that easy to extend. So sometimes you actually won't know what the answer is, but the idea that if you're doing scenario-based development with your users and you sort of get an early signal about the kinds of things they might want to do, no magic bullet here, but it's a way to try to identify early on the things that plausibly might want to change in the future. So again, these are all best effort things. You will not find yourself always getting them right the first time. So you can try to close against the types of changes that you're pretty sure are going to be extensions you want in the future. Sometimes you'll miss. That's life. Summarizing, open, closed. Where are we? It says that if you're extending the functionality of a class, maybe by adding additional variants of what it can do, that should not require modifying any existing code, just adding new code. And what can you look for as a yellow flag that you might be doing this? Well, the canonical version is something like that I showed, which is whatever set of ways there are to do something, somewhere in your code there's basically a hardwired multi-way dispatch that picks one of the ways. That means that if you need to add a new way, you have no choice but to go somewhere into that dispatch function and start adding clauses to it. And again, it's easy to sort of creep into this without realizing it, because if you were doing this in a compiled language, every time you have to add something, you've got to recompile. And now all the other developers who depend on your library are being notified that they have to relink against your newly modified library, and then they hate you. But here, that never happens. So what can you do if you find that you have this problem? In our example, we applied a couple of different things. We started with abstract factory because that lets you essentially not need to know at runtime what all the possible values are of the variants, as long as you have a class that can implement each one of them. Then we decided, depending on the kind of task you're going to do you try to capture it as a template method? So you have a superclass that does a fixed set of things, but then you've got subclasses that override the implementation of each step. Or is it more general and you try to just capture it as a strategy, which means you have a component in the base class that says, I am an example of a formatter. You can call output on me, but don't make any assumptions about the internal sequencing of steps or anything like that. And then we also saw that if you go that approach, it gives you the possibility of also adding incremental behaviors and sort of stacking them up on top of the base class. Right? Not every example will necessarily have all these properties, but that's kind of our summary.
All right, so that's it for today's lecture. We'll continue our discussion on design patterns next week. So just quick recap. Today we've talked about just an overview of design pattern. And again, don't worry about that if you don't fully understand what we've talked about so far. It's perfectly normal. Usually it takes a few times. It takes experience, and then it takes just reading through or watch through the videos a few times to have a better understanding. And then we've talked about the S, which is SRP, single responsibility, and O is just open close principle. That stands for the first two of the solid acronym. So next week we'll talk about the remaining three. I have some comments on composition over inheritance, which we've already looked. If you look at a few examples with the previous few videos. Okay, yeah. So that will conclude our lecture today, and I will see you guys next week. Bye.